Some scientists believe that the average surface temperature of the Earth has been rising steadily. They have modeled the temperature by the linear function T equals 0.02 T plus 8.5, where T is the temperature in degrees Celsius and T represents the years since 1900. So there's a lot to take in here. We need to be very careful with how we interpret this. We have the uppercase T for T equals, and that is representing the temperature. Then we have a lowercase t for our variable, and that is representing the time, and more specifically, it's representing the time since 1900. So the same variable is used here, uppercase and lowercase, but they're being used for two different meanings. So we have to make sure that we are differentiating the variables. In part A, we are asked what are the slope and the t-intercept. The t-intercept would be the same thing as a y-intercept, but this time our variable is uppercase T for the y, not a y. So it's called a t-intercept. And what does this represent? Well, remember, if we have our equation in the form y equals mx plus b, then we can read our y-intercept off because our y-intercept would be the value that is by itself, the constant. So the plus b. Well, even though our variables are capital T and lowercase t, we still have that same format. We would have in this case T equals m little t plus b. So our y-intercept would be our 8.50, same thing. So our t-intercept, let me write it with the capital, is our 8.50. And what is the slope? Well, the slope is the m, and the slope is the value that comes before the variable when you have your equation solved for, in this case, uppercase t. But in general, when you have it solved for y, it's the value that comes before the variable. So in this case, our slope would be the 0.02. And what do they represent in this context? Well, if we're looking at little t being the time since 1900, then our t-intercept would be the average surface temperature in 1900 when lowercase t would be 0. So this would be when t equals 0, then t would equal 8.50. So this means that this is the average surface temperature in 1900. Now our slope is 0.02. The slope is the rate of change. So that means that we are looking at how the temperature is changing in relation to the slope. So our slope is positive, so that means that we are seeing an average of the temperature increasing by 0.02 degrees Celsius each year. If our slope value was negative, then we would see an average of decreasing. But in this case, our slope value is positive, so we are looking at an increase. In part B, it says use the equation to predict the average global surface temperature in 2100. So that means that this is going to give us our little t. But be careful. Little t is the time since 1900. We're looking at 2100 now. So that means we need to figure out how much time has passed. So let's do some subtraction. 2100 minus 1900 looks like that's going to be 200. So this is telling us that little t is 200. Well, we know that our equation is uppercase t equals 0.02 lowercase t plus 8.50. So that means we can substitute in 0.02, our 200, in the place of our lowercase t. And we still have our plus 8.50. So if we multiply this through, it looks like we will get 12.50 degrees Celsius. So that means that our estimated temperature in 2100 would be 12.5 degrees Celsius.